All right. This is example 4. This is the example that was not in the lecture earlier today, and this will benefit you. You're going to have at least a couple of problems. I think 3 problems where this is going to benefit you. So for this example, we have m to the 6th minus n to the 6th. It is not a difficult problem. There was just something about it that clearly I took for granted. Every once in a while, I assume like, oh, everyone knows this. And then I realized, well, that was a bad move, dude. So let's get down to it. What is this? It is a difference of cubes. It is also a difference of squares. Watch out for those exponents that can be divided by 2 and 3. And also watch out for numbers like 1 and 64 that can be square rooted and cube rooted. It happens. So which route are we going to choose? Squares. So we're going to treat this as a difference of squares. And when we initially attack it, I don't need A, I don't need B, I just need 2 sets of parentheses, equal size, no short set, long set. What is the square root of m to the 6th? So m cubed goes here, and m cubed goes here. Trying to color code this in case you're still a little lost on the squares. What is the square root of n to the 6th? So I put n cubed here, and I put n cubed here, right? There are some signs in there. Just make sure that one of them gets a plus and one of them gets a minus. Order does not matter. What have we spawned? Yeah, one of each, right? A sum of cubes as well as the difference of cubes. So we've got our work cut out for us, but it's no big deal. What the conversation we've had so far was not the impetus for this recording. There's one little part, and I'll point it out when we get there. So knowing that the first part is the difference of cubes right here, what is my A value? Did I say difference? It's a sum of cubes. Sorry, what's my A value? And what is my B value? Nice. So let's go ahead and work out short set, long set for this first guy. What's short set going to be? M plus N. Next one. Yeah. And then the next one. Yeah, so A is M again, and B is N again. And again, structurally, they're identical. The pieces, the AB, A squared, AB, B squared are the same. It's just the signs are a little bit different. And actually, this was not the example that I wanted it to be. So if you don't mind, I think I'd like to whip up one more. And if you want to, I can do one of your homeworks with you. We'll see. Anyways, this one was pretty anticlimactic. Then long set is going to be M squared plus MN plus n squared. So yeah, that one did not have the meat on the bone that I thought it would. Any issues with that? Okay, check this one out real quick. Let's just knock this out. This will take about 2 minutes. Huh? Yeah, this will be just like one of your homework problems. So make sure you get this one jotted down. I'm just changing the letters because I don't like the ones that were in the problems. Was that last one a summer? Oh, it has to be a difference. Oh, no, it doesn't. This will answer a couple of different issues. First off, what is this? Sum of cubes. Is it also a sum of, or can it be squares? No. No. It's trash for 2 reasons. Number one, it's a dang plus sign. And number 2, 9 cannot be divided by 2. So we're going to attack this fully as a sum of cubes. So what is A? Nice. And what is B? Yeah, nice. So now that we've got that, we got our short set, long set. Let's do this. So I got a short set and I got a long set. What's going to go in short set? A plus B, right? M cubed plus N cubed. What's going to go in long set? This is it right here. This is the moment. This entire example exists because 2 people whose math skills I have infinite respect for asked this question within 30 seconds. And I was like, ding, you better say something. Do you guys know what's going to go in the middle? This is what I'm talking about. And I learned so much as a teacher today about how never to take this for granted again. I've heard some interesting things. This is way less exciting than you think it is. Remember, what always goes in the middle, always, is a times b, right? So all I have to put in the middle is m cubed n cubed. Like it's almost crazy to do an entire recorded example for that, but that's what goes in the middle. It does. There's no sixes or nines involved. It's just literally a mashup with a and b. Just boop, stick them together and call it a day. And then what goes at the back end? Yeah. And I could finish this with you if you want to, but really this is just another, let me underline it in red for you. This is of course just another sum of cubes, right? So I bet you could probably finish this from here. Would you like to finish or are you good? Let's finish, okay. So now that we've got it down this far, we recognize that long set is off limits, but short set is another AB, short set, long set. So what's A? What's B? All right, so now it's time for us to create a new short set, long set, while also copying down the original long set. All right, what goes in my new short set? M plus N. And what goes in my new long set? That is what you're doing today, is you're learning how today to factor things when cubes spawn more cubes or cubes spawn squares. That's the idea. And then tomorrow, hopefully we hit the very top and then we work hard for a few days to get ready for the next big quiz. It's going to be a whopper. So, all right, good. I'll leave the recording going. And if you guys have any questions, then I will just keep adding on to this one since I'm already going to post a second video. It says 64 y to the sixth minus 1. 64 is one of those numbers I talked about that can go kind of on either way, on either path. Yes, it's a cube, I get that, but it's also a square. And 6 is one of those really annoying exponents that, yes, can be divided by 3, but also can be divided by 2. And if your exponent can be divided by 2, you are by definition a square. So I look at this and I say, I know I could do this another way, but if I want to do this the best way possible, I'm going to perceive you as a square and you as a square, because I know I'm going to get more out of this if I do it this way. I know it. So when I take the square root of the purple thing, what do I get? I get 8y to the third, and that goes here, and it goes here. When you square root something that has two factors like that built together, you square root each of them independently. You square root the 64 to get the 8, and you square root the y by taking half of its exponent. How about the red thing? What's his square root? So you put a 1 here and a 1 here, and then, of course, because they were squares, you plus and minus it to make the middle cancel. Make sense? Now that we've come this far, let me color code this for you. What is the green thing? It's a sum of cubes. And what is the yellow thing? It is a difference of cubes. And so I find myself in a position now where I just basically have two new math problems to do that are going to be essentially identical except for the signs. So A is what? Good job. And B is, and then on the second one, A is, and B is, right? So again, the structure of it is going to feel like the same thing. The AB, A squared, AB, B squared is going to be the same stuff. So when I do my two green pairs of parentheses, short set, long set, what do I put in there? But my yellows. Jackpot. And if you do it the other way, where you observe 64 y to the sixth and one is cubes, it works. It's just not as good. Less factors. You should have already encountered two problems that can be seen as a difference of squares and as a difference of cubes. Both one and two, you could go both ways on, and I hope you picked squares for both of them.